So without further ado, I'm going to introduce Al Buehler, who's a Distinguished Service Professor of Transportation Systems and Policy at Hinds College, as well as Chris Hendrickson, who's a Professor of Engineering and a Director of the Traffic 21. And they're going to present to you guys PA's Vision 2040 plan of what the autonomous vehicle and connected vehicle test bed could look like here in PA.
So I'm Chris Hendrickson, and Al and I flipped, and I won the opportunity to go first. So I'm going to do a little bit of an overview on Traffic 21, since I think a lot of people on campus aren't really aware of what's going on with Traffic 21. And then I'll do a little bit of an introduction on connected and automated vehicles. We kind of thought some of the audience wouldn't be up to speed on a lot of the technology that exists. I can look around the room, though, and see a number of people who are pretty expert on the topic, so I'll try and be pretty quick on that. I'll show a couple of videos just for fun, and then turn it over to Al to talk about our Vision 2040 project for the Pennsylvania Department of Transportation. So just to reiterate what Zoe just said, Traffic 21 officially became an institute this last July. It had been around for about 5 years as an initiative, and we decided that it was time to switch from an initiative to an institute and be a little more institutional about things. And then the other big entity that's happening on campus is the University Transportation Center, which is called Technologies for Safe and Efficient Transportation. And since the formation of Traffic 21 5 years ago, there's been an emphasis on research, development, but particularly deployment and transfer. So that we've tried to make regional alliances with the city of Pittsburgh, the county, governments around the western Pennsylvania area to try and deploy technology out into the world and demonstrate how it can work and make changes. Traffic 21 is very much multidisciplinary. You can see participating organizations here: fine arts, robotics, computer science, engineering, Hinds College. Couple of things that I'll pick out on this. The Mobility Analytics Center has started up last year, and we're trying to get real-time feeds of performance from around western Pennsylvania and use that for trying to improve the performance of the transportation systems. Metro 21 is just starting up. It's another initiative, and the transportation parts of that are pretty much jointly managed or run between Metro 21 and Traffic 21. But of course, Metro 21 is a larger entity in the sense that they're interested in all the systems associated with the city. And just a couple of examples of things that Traffic 21 has been supporting over the last 4 or 5 years. First is a set of projects that are intended to provide better intelligence to users of the transportation system. So giving information as people need it to make decisions in real time. The one on the left is to give information about parking availability in the downtown. The one in the center, Tiramisu, gives information about transit. I rode the bus home yesterday because it was icy out rather than walk, and I used Tiramisu to figure out where the real-time routing was for the buses going out towards my home. It's a free download if anybody's interested. NavPal is intended to provide information for people with disabilities to get around. Bringing greater intelligence to managers of the transportation system. We have projects going on road conditions, and both in terms of potholes and in terms of snow. Christoph, if anybody has questions about that, he's the guy who really knows that topic. Managers of the transportation system also have to worry about things like bridges, and so we have a project going on with indirect bridge condition monitoring. Essentially, it's using sensors running along on the Port Authority trains right at the current time. One of the things that's been deployed in the local area is an adaptive traffic signal called SurTrack, and this is software that is out there running traffic signals right now in the East End primarily, and it's showing some improvements in the performance of the signals. So this is Bakery Square right in here, and you can see the signals that have been moved into the SurTrack software. We're trying to expand SurTrack. Fall 2014 was just around Bakery Square. It's now moving out Penn Avenue in both directions, and we're hoping that we're going to be able to move the software into a downtown implementation in the next few years. Carnegie Mellon is right down here if you're interested in where we are. So this is just a little bit to our north, this set of signals. Bringing greater intelligence to vehicles. Headlights that see through rain and snow using new sensor technology to try and improve the visibility that you get from driving. And then a whole series of things that have been going on with respect to connected and automated vehicles. And that's what I'm now going to turn to. That was kind of your overview of Traffic 21 and some of the things that Traffic 21 is trying to do. I'm now going to talk a little bit about kind of the technology of connected and automated vehicles, and then I'm going to turn it over to Al to talk about really the policy implications of this new technology. And the first thing you should realize, this is disruptive technology. This is going to change how the transportation system performs. It's going to have significant implications for urban form, where parking lots are, where they're not, and where people are choosing to live. So this is a technology that I think is going to have a profound impact on you all over the next few decades. And just a little bit on terminology. Zoe already talked about connected vehicles. These are vehicles that communicate through dedicated short-range communication technology of one kind or another. And you can see it's not just light-duty vehicles, but it could be trucks, it could be buses that are communicating. And you can have vehicle-to-vehicle, vehicle-to-infrastructure, so that you can communicate with traffic signals. And so an automated vehicle can learn from the traffic signal whether it's red or green or whatever. And then you can do vehicle-to-other. You can go to the cloud, you can go to satellites, you can go to bicycles, pedestrians. That's what I want, by the way. I walk to and from campus to my home. It's a little over 2 miles every day. And I would say about 10% of the vehicles do not give me the right of way when I'm going through a crosswalk. And so I want to be able to register some disdain for these vehicles that are trying to cut me off all the time. So, and in addition to connectivity, you've got a whole series of vehicle sensing that's coming into play. You can have views, you can have distance measures, you can have rear collision warnings. I actually have that on my car, so if I get too close to something when I'm backing up, I get this ping, and suddenly I know that I shouldn't be doing that. And you can have a whole series of sensors on vehicles. This is the old DARPA Challenge 2007. It was the vehicle that Carnegie Mellon used in the challenge for autonomous driving that was arranged by the Department of Defense. This is a timeline that was just put together about research that happened here on campus for automated vehicles over the last 30 years. So this is research that's been going on for a number of decades on campus. You can see it started up in 1984 with the Terragator. I remember when the Terragator was programmed to follow straight lines. And I remember one day it was out in Flagstaff Hill, going up the walkway in Flagstaff Hill, the asphalt walkway that's there, looking for a straight line to follow, and it found a tree, and it started up the tree. Okay? By the way, it didn't go any faster than you could walk, so you could walk right beside the Terragator back in those days. As you might imagine, perception has improved since those days. And you can see that not only have perception and the software improved, but the vehicles have gotten more similar to conventional vehicles that you and I might be driving. So this is just two versions, 2007 and then the Cadillac in 2012, and you can see that the Cadillac really does look like a vehicle that you could take out onto the roadway. Trunk space has really changed too. Back in 2007, we had computers that took up a lot of space for doing all the computations associated with sensing and modeling for the environment. Now you can put it all beneath a typical trunk. So kind of the technology that's happening is to try and take these autonomous vehicles and put them together with connectivity, and so that you've got connected and automated vehicles with capability for doing all sorts of things. Intelligent routing, avoiding collisions, avoiding crashes of one kind or another, platooning potentially, those types of things. Oh, I thought I'd talk to you a little bit about a couple of demonstrations that we've done in the local area. Well, not in the local area, but here's one in the local area. This was a drive from Cranberry Township down the interstate and off to the airport. So 33 miles. Here's a picture of the destination at the airport. Here's a second demonstration that we did in 2014 down in Washington, D.C. Raj was the one who was really in charge of this. Went through 21 signalized intersections, and it went right around the Capitol. And these were the people that were riding in the vehicle, and you can see the vehicle in the background. And this is just kind of the talks that went on in association with that. That's where I'm going to try and hope that I can get some videos to work.
The future is coming to our streets and our highways in America in this autonomous vehicle.
1.2 million people die every year in automotive accidents on a global basis. More than 90%, maybe 93% of these accidents are due to human error. So humans can be distracted, can be angry, can be drowsy and all that. So basically if computers are in charge, none of those distractions are happening, and we expect that accidents, fatalities and injuries will go down dramatically.
Basically the way it works is you twist this pops up, puts the car into autonomous mode. Now everything is controlled by a computer. You'll see the steering wheel move, you'll feel the car accelerate and brake when it should, and also at turns you'll see the turn signals come on.
We have a laser behind the glass and a radar behind the glass for detecting obstacles, vehicles or next lane. We have a laser here, we have a radar there, we have a radar behind the bumper, and we have a rear view camera.
Talking to the experts, they believe they can be deployed into the fleet within 6 to 8 years, and then about 15 to 20 years they'll be available in the fleet with about 75% of our vehicles. Who would have ever thought we'd be sitting here talking about autonomous vehicles? So, you know, George Jetson may be a reality.
Okay, that was the Washington Post video of that.
See, your heart's kinda funny when you tell you something feels right. So call it your intuition, I just see in the light. Maybe you
I mentioned platooning, that's platooning. And you can see for the Volvo case, they were using a lead truck to control the platoon, but that isn't necessarily the case for all platoons. You can have just self-organizing platoons. Well, with that, I will talk over to Al.
Okay, I'm Al Baylor with Heinz, and I want to talk a little bit about now the sort of the transitions. First of all, this is a slide that was produced by one of our colleagues at General Motors. As you know, CMU has a General Motors lab, which is really what ultimately produced the most recent version of this autonomous vehicle. Their projection is that, clearly there's probably a series of steps, but we're well on our way to having incremental changes. As you know, today you can go to your favorite car dealer and see a very different array of options. Before it was, do you want a sunroof? Now it's, do you want to have so-called super cruise? The kind of cruise control that not only speeds up and slows down, but also stays in lane and those kind of things. And the question is, how far are we and where are we going to go and how fast? Different folks have different opinions on how fast we finally get to a situation where you can have a completely autonomous vehicle, where basically you get in a vehicle, you don't need anything other than a sort of a keypad to instruct the vehicle where to go. But that's ultimately when you get to a completely chauffeured kind of a system. Let me see, what do I need to do to move this, Chris?
Just hit the arrow.
The arrow's not doing anything. Not happy.
Yeah. See? There you go. Just hit it hard.
Okay. Well, first of all, just to show you a little bit of the transition, Mercedes this past summer was in the process of testing an autonomous truck out on the Autobahn. And people have made various projections. One of the things is with legislation that allows systems like autonomous driving, will they be in place and how fast? The folks at Daimler Benz are clearly focused on that and trying to encourage different changes. And they think by at least the middle of next decade we'll have systems in place to deal with that. I know last September Elon Musk pointed out that he thought he could have vehicles at least in a time frame of 6 years from now. But again, it needs to have more perfection in sort of the whole vision, machine vision technologies as well as sensor technologies to be able to accomplish that. There's an awful lot of activity going on in various states. Some states, the states shown in blue here, already have legislation in place that allows vehicles to be operated formally in autonomous driving. Although I have to tell you, you saw some pictures earlier about the demonstration that Carnegie Mellon did here in Pennsylvania. There were some frantic calls before that demonstration back and forth with the state police. And I personally was involved talking to the Pennsylvania Department of Transportation Chief Counsel saying, is this permitted? Well, and the real answer turned out to be that, like most states, nobody anticipated autonomous vehicles when the vehicle laws were put in place. And so the statement in Pennsylvania says that the driver has to be in control of the vehicle. So we were saying, well, yes, we have someone behind the wheel to take over if there's a problem. So yes, a person is in control of the vehicle. And they said, okay, that's all right then. But anyways, what's happening in other states is actually having formal requirements to do specific testing. And it really was started in California with the urging by Google and has spread. So some states are still in the process of thinking about it. Others have passed legislation. Others have decided at the moment not to act. And that may be the smartest thing, because ultimately it would be pretty difficult if you had a patchwork quilt of regulations across the United States. So clearly the federal U.S. DOT and their association, namely the National Highway Transportation Safety Administration, is getting into the topic and looking for folks to help educate everyone to see what to do. Anyway, so that will no doubt progress as more and more technology is available and perfected and so on. Barry Shoak, PennDOT's previous secretary, was looking at, he and I were talking about autonomous operation and connected vehicles and so on. He said, you know, is it time for the Pennsylvania Department of Transportation at least to learn more about it? And his answer was yes. As he thinks about the kinds of things that they deal with every day, one of the things that really pushed him was issues related to infrastructure investment. Well, if you know anything about infrastructure investment on the highway side, typically if you're going to make a change that you've got a facility that you either want to expand or a new facility, first thing you do is make a 25-year projection of traffic volumes. Well, in 25 years, something is going to be pretty darn different than it is today in terms of autonomous vehicles and so on. So he said, at least I ought to have a box to check. So help me think that through. And the you part of helping me think it was Chris and I and a woman named Yagani Hayeri, who was a PhD student at the time under Chris, and she's now since completed her work. But anyway, we in fact we did some work, you know, looking at those kind of issues as requested by PennDOT, at least to start the thinking process. So let me just share just the general, a few of the things that we ended up talking about and suggesting. First of all, Barry Shoak, the secretary, said, I really want to ultimately focus on year 2040, just to pick a year that by then certainly something will be very different, so help me. Then he said, well, leading up to 2040, what should I start thinking about? First of all, in terms of the capacity enhancements, the things I just mentioned, what can an autonomous and connected vehicle do today that a manually driven car cannot do? And that is, because of driver distraction and so on, a vehicle that's autonomous can probably stay in a much more rigorously controlled area. Namely, you can stay in lane, and maybe you can even have things such as less lane widths. If that vehicle also doesn't run off the road anymore, do you need a 30-foot wide median in the middle of a freeway? I can only tell you, if you're in an urban area especially, the cost of buying right-of-way to expand a highway is astronomical. Big high freeways are costing, you know, a few $100 million a mile because of all of those kinds of things and utility relocation. So the first thing we said is, look, if you've got some really big investments on the docket, PennDOT has been spending a lot of effort trying to rebuild this system simply because of deterioration, but they sure have a handful of really big projects on the docket. Start thinking about, given whatever your projection of traffic is, as to what a vehicle might be able to do, and maybe you want to not reconfigure or not expand the system, but maybe look for opportunities to reconfigure what it was in your current right-of-way. Maybe use some of the median, potentially, maybe delay some of your investments until the time when vehicles may be able to stay, you know, have a much more greater population of autonomous and connected vehicles in the stream, and then make your investment. Anyway, it's a pretty daunting task because you're trying to predict the future, but you also want to use the public's money pretty wisely. Another one is a huge opportunity. Pennsylvania Department of Transportation produces information and gathers information about various incidents across the state. And the question is, what do you do with that data? What we said is, the more you can provide it to in an open public forum, if you will, you're going to find lots of private sector folks who are doing, you know, producing new apps almost daily who want to take advantage of it. That helps you ultimately provide real-time traveler information systems to the public. So it's to your benefit. Next is, Chris talked about the whole vehicle to infrastructure application, being able to talk to, if you will have your vehicle talk to a traffic signal or in some cases other roadside receptors and so on. We suggested start thinking about investing in a few of those on a test basis to really learn what their capabilities are. So that was another one of the issues that we think is important. Another one is is the whole issue of driver training. Pennsylvania DOT, as you know, both registers your vehicle, but it also has to issue driver's licensing based on testing results, both as a written test as well as an actual test in the field. Well, what happens now for one of the things has characteristically been, can you demonstrate you can parallel park? Well, you know, you can buy a car that self-parks, right? So how do you test? Are your testing procedures in line with the change in technology? So as the transition goes, one of the things we suggested was for those kinds of technology changes that you can now have in your car, if you can turn that technology off, like you can with Super Cruise as an example, then you ought to test manually. But at some point, if the technology is now so embedded in the vehicle that it automatically, you know, does certain maneuvers by itself, and you can't turn the system off, well, then you're probably going to have to revise the way you do testing. So they're on the lookout for those kinds of things. Another one is one of the things that happens at PennDOT in terms of freight movement is, one of the things that's kind of interesting is, what do you do with oversized loads that are just have two really great heights to them or great weights? Well, Pennsylvania DOT helps the truckers to route. You have to get a permit from PennDOT to route on a special way. There's an opportunity, because also that has to be enforced to make sure people aren't driving vehicles where they shouldn't, especially in terms of weight. There's an opportunity here now to use this new technology in concert with the state police to figure out automated ways of doing this. Today, there's no reason why you couldn't have an overheight warning system both in the vehicle as well as, you know, pegged to your infrastructure for all bridges that are restricted to 20 tons, as an example. If you had a way to communicate that to the vehicle, you could have the vehicle avoid those facilities. So anyway, there's some opportunities that way. Also working with the state police that they're now investigating. This whole equipment of infrastructure and so on, that in the period when you get to 2020 and beyond and 2030, you really probably are into some real significant implementation. I should mention that in this world of so-called connected vehicles, the National Highway Traffic Safety Administration is in the process right now of developing regulations that will require automobile manufacturers to have connected capabilities beginning in probably a couple of years. So we'll see that. In fact, what's really happening is, as you could guess, the manufacturers are in fact jumping ahead of that and starting to provide that on their own. Workforce training, another one is, obviously we've got a whole workforce. There's a series of 12,000, almost 12,000 people at PennDOT that are used to, you know, not old, but, you know, current ways of doing their work. Well, now if you've got a connected and autonomous system, you probably need to understand what those capabilities are, not only to be able to understand the electronics and those kind of things to the extent that they're using at PennDOT, but also that potentially they can change and look for new opportunities. I mean, ultimately, can you imagine having a snowplow that is now automated and without a driver? Well, it sure would save on the cost of a system, as an example. So they're taking a look at a number of things. When we said finally when you get to 2030 and 2040, and, you know, whether these time frames are exactly right, we'll see how fast the technology moves, but we think you can actually now repurpose lanes. So perhaps you want to now manage your system differently. Maybe you want to have all through-bound vehicles, you know, managed, automated in an automated way to be in one particular lane, or just simply have an autonomous driving lane or a series of lanes that is part of your mixed traffic. Another one is, we thought the last one was kind of fun. We said, eventually you're going to get to the point where people will have antique cars, and you're going to probably have to have a special license and make sure that they can drive a manual car, because everybody's going to have an automated car. There you go. But anyway, we'll see what happens. What really this does, it really triggers then, you know, it makes you want to stand back from this whole process and say, well, wait a minute. This really is a significant change. And there is probably some research that really needs to be undertaken pretty rapidly. And in fact, it's catching on as we speak. There's a whole series of Transportation Research Board activities and committees that are saying they're trying now to drill down and say, let's get going on these various areas. Let me just mention a few of them. First of all, obviously, there's the opportunity to reduce fatalities and injuries is huge. And we really ought to go after it with a vengeance. But now the question is, on this, as you can see, this question about what are the states doing? Do they have responsibilities, and how should they regulate? Also, there's a real issue in the insurance industry. Today, if one of us has an automobile accident, we probably have some responsibility ourselves because we're the person behind the wheel. And if tomorrow you have an accident, figuratively, in an autonomous vehicle, now who is it because there was a glitch in the mechanical systems or electronic systems, or what was it, and who owns that responsibility? Does that now go to the car manufacturer, or is the owner still? Anyways, so you can see that there's those kind of issues are going to have to be thought through as well. But as I say, the payoff is huge potentially in lives saved and injuries and so on. Another issue is mobility and access. You've now got folks today, in Pennsylvania, there are certain ages that you have to have a driver's license. Well, wait a minute. If you're 14 years old and you can pick your destination, shouldn't it be okay to jump in a car? Maybe so. Also, the changes it may bring in terms of people's lifestyles and just access opportunities will make a difference. And there's economic changes as well. So part of it is predicting what is likely to happen, understanding that, and the real question on all these policy things is, do you want to take certain actions to either accelerate it or incentivize it? What makes sense? In the case, there's a couple other issues here of what happens with congestion and vehicle miles traveled. Vehicle miles traveled is a measure typically used on an annual basis just to kind of see the level of transportation activity. In recent times, it was almost like clockwork that you would see a 1 or 2 or 3% growth each year in vehicle miles traveled. That changed in about 2005, 2006. It kind of leveled off, and in fact dropped a little bit. Will that now change? Will that grow higher? Will it continue on a downslide? A lot of folks are suggesting maybe it will increase because people have, a bigger population has freedom to choose travel. Well, we ought to know about that. Can you simply on crowded freeways absorb any changes and increase in travel because now you can operate the system more autonomously and have it be more efficient? So it makes this travel forecasting business that we know today probably either obsolete or sure it's going to at least change it. And there's in fact research going on along those lines and needs to continue. Public transportation. What's going to happen with public transportation? Is there going to be more opportunities for more public transportation? On the flip side, will be more ride sharing in more cost-effective systems? Will it undermine the effectiveness of public transportation? Or could you somehow capture both worlds by having more efficient intermodal links? I know I can tell you that just last week there was a group from Siemens from Vienna who are doing research about intermodal links. So they want to say, jeepers, do we understand if we could have a car share link for this part of the trip and a bicycle trip or a pedestrian or a part walk trip or part transit and part rail or part auto, what might it look like? But it's important to understand, again, what the potentials are here. And again, is there a tipping point? If you made certain parts of it more effective, would it attract more people to public transportation, as an example? We're going to be doing here in Pittsburgh. Chris mentioned that there's this adaptive signal system that we've expanded through the Robotics Institute folks. And Bauman Center, 23 locations are going to be added to the current 20 plus. We're going to have nearly 50 intersections here operating in the spring of this year. One of the things we're doing is setting up connected vehicle capability at the Bauman Center corridor. But one issue here is, can we get transit vehicles? We're working with the Port Authority to put some radio communication equipment in those buses. Can we get those buses to have priority through that corridor? And will that then ultimately allow Port Authority to offer more on-time service and cost effective, and can you then draw in more people and make it more reliable? So those are the kinds of things to think about. On the energy side, Chris showed you that little video that Volvo produced, looking at platooning opportunities. There, and by the way, the energy consumption dropped. There's energy savings of between roughly 10 to 20% simply with platoon vehicles. With a much smoother flow of operation, you can really get some interesting energy and therefore the associated air emission reductions as well. So the real question is, how can you facilitate that as well? Rand did some work that said if you in a real idealistic world, you may get way over 300 or even 500 miles to a gallon with some really different automated pod car kinds of concepts. So interesting. It at least makes you want to take a hard look at that. On the land use side, people make land use their home location decisions. Businesses make business site development decisions based on where they are. Or based on transportation issues. This is going to change that world too, we think. Let me just finish up here and then we can see if there's time for a few questions. Last but not least, on the economy and job side, potentially you've got much more efficient logistics moving freight. Also, people may be displaced. Lots of people who are vehicle drivers, may see their world change. The whole instance or the issue in the crash industry, whether it's insurance or fixing vehicles, that may change if there's less vehicles crashing. So, bottom line is there's an awful lot going on in this co-connected and autonomous vehicle. There's the mechanical, electrical part, making sure sensors are working great. Then there's the whole question of policy, and the real issue is, will we understand it well enough so we can take advantage of it? So let me just do with that. Let's Chris and I open the floor and see if there's any general questions we can answer in the remaining few minutes. Question?
Questions?
Yeah.
So I know you mentioned public transportation a little bit. What are your thoughts on the potential for autonomous taxis?
Yeah, sure. Why not? I mean, obviously, there's a recent announcement with Uber looking at ride-sharing kinds of opportunities. Sure, why not, right? It's no different than if you have an autonomous vehicle yourself and can direct, tell where to go. No reason why you can't order up a taxi.
Do you think the government or like the local governments are going to adopt autonomous taxis or try to keep them out of the market because of like undermining the current taxi market?
The crucial policy step, I think, is going to be when you allow vehicles to drive without a driver behind the wheel and ready to take over. That's going to be a major step, and we're going to have a lot more confidence that the technology is reliable and that type of thing. I think the first step you're going to see towards that will be cars that park themselves and without supervision. We've actually already demonstrated that out here in Moorwood parking lot. And you're going to start seeing applications of that in private sector or public sector parking lots, I think. So there's a path forward for going toward that crucial step.
Do you guys see anything about the future of maybe human-powered autonomous travel? It's an autonomous bike where you pedal but it steers, or maybe whole train systems where the passengers are pedaling or something like that, something that kind of fuses this idea of autonomousness and biking, which are both kind of have the same goal.
Yeah, I don't know if there's any big advantage of going automated for bikes, but certainly the connectivity can be helpful. And you're already seeing a whole bunch of apps coming along for serious bikers to get better routing and that type of thing. I'd like to see, in the same way I was talking about notifying cars that I'm walking and crossing the street, you'd like to have cars notified that they're getting too close to bikes and avoid crashes. So that would be a big advantage.
Yeah, have you all been studying any like potential lifestyle changes in terms of ownership, similar to like the autonomous taxis, but like in collaboration with systems like Zipcar, for example? Like the people who commute to work every day may no longer need a car, so like you sit at home when you go to the grocery store, just call a car to your house, and it'll take you there.
I don't know that we have, but I know that, in fact, we had a guest speaker here that Kristen invited in, a woman named Dr. Kara Kockelman from the University of Texas, who studied different, that kind of issue about how are people now going to change. Will they, in fact, have, will auto ownership reduce because you have the shared capability? Or, what's the flip side? Will people now say, well, jeepers, I can live farther out, change my home location, still have an autonomous vehicle that takes me, into work, wherever work is, and I can do other things while the vehicle is driving. So it's interesting to try and figure out, on one hand, there's an opportunity to have reduced travel, ownership, and so on. On the other hand, it may go the other way. So that's what the reason for.
You can already see people making decisions to drop cars. My son sent back his car last year and decided to just go with Zipcar.
Can you speak a little bit more about the possibility of a drastic increase in congestion and fuel use? When people no longer have to drive their car to the store, they can just send the car places. So you have a massive increase of cars on the road going places with no people in them.
That's true.
But seriously, because as soon as a car can drive itself, you don't need to be there. I mean, so unless you're going to work, you could just send the car.
Yeah, it could be, I drive downtown, I get dropped off to go to my workplace, and I tell the car, well, go back somewhere else in the park. So I'm not paying the parking charges downtown. So yeah, we may well see an increase in vehicle miles traveled. The hope is that with the new technologies and sensing that we're a little more intelligent about avoiding congestion, using the capacity of the roadway system more effectively.
Has the issue of cybersecurity been arise because of potential for like malicious use, or if somebody like hacks into the system and says, okay, I want the car to drive here instead of there, is there some sort of like kill switch or preventative action? Or it seems like because everything's like more connected, it could seem like there opens up the potential for, if one person does something, it could cause a lot of problems for a lot of people.
The answer is yes, and underscored. Absolutely. In fact, one of our partners at the University Transportation Center, our partner, which is at University of Pennsylvania, they've been doing some work specifically on making sure that there's systems in place to verify that the information is coming from a proper source and so on, because opportunity, you would think, to interfere with that whole stream of information is pretty rich. So yes, cybersecurity will continue to be a huge issue all the way through the transition into connected autonomous vehicles.
Already is for the current generation vehicles.
Yeah. Yes.
Has there been much thought put into, say, fast forward 50 years when pretty much all the cars on the road are autonomous, that one person who wants that old manual license, a lot of the efficiencies we're talking about in terms of lane width and spacing between cars to allow for a higher volume go away with that one person, so the best driver isn't really able to meet those same things. How does that, has there been much thought about that?
Well, there's been some early work leading up to that to say, well, what happens if you have 10% of the vehicles on the road? One of our researchers here, one of the faculty members, Sean Kian, has been wondering out loud that maybe in fact becomes less efficient, because maybe with autonomous vehicles, at least initially, you provide you basically program a vehicle to say, I need a gap of this much because I want to be conservative. So he was saying maybe initially it's sort of there's a downside, but yes, then there's that phenomenon as well. So I don't know yet what happened, but yeah, I sure want to think about Because you're going to then restrict manually driven vehicles.
Yeah. You may have restrictions on where they can be driven.
Sure. Interesting. Yeah.
On that same note, say is adopted 50, 60 years, and all of a sudden we have autonomous vehicles everywhere. In terms of the frequency spectrum, has there been a significant amount allocated to that, or because I mean that's a highly scalable space and it would require a significant portion, right?
Yeah.
So I was just curious.
Yeah, I don't know. We come to the next seminar on connected vehicle pilots, and you can ask the experts on that one.
Yeah, but there's absolutely a lot of discussion with the FCC and others currently going on about that.
NHTSA moving to start requiring connectivity, basically reserved a piece of the spectrum for that purpose. Right. And that there was battles going on for how that spectrum would be allocated.
We'll get your own diagram.
Okay.
Have any of the CMU cars that have been autonomous, have any of them had a flat tire while running autonomously, and is there any software for that?
Not during the demos.
Not during the demos?
Yeah, thank goodness.
What happens at late at night, who knows?
It's just a matter of time.
Exactly.
Down here on the floor.
Before the fully autonomous cars, there'll be a phase where we have semi-autonomous cars provide maybe it takes over on the highways and the person is driving in the residential streets where there are no lane markings and stuff. Is there any thought going into policy for that kind of thing?
I'm not sure.
For the semi-automated cars. Right now, it's just the automakers that are starting to introduce those. And actually, I have a graduate student right here, Corey, is trying to figure out whether those partial automated systems are having a significant impact on the crash rate for the cars. So you can talk to him about that.
I know. There's a guy who used to be the deputy director of the National Highway Traffic Safety Administration who was hired by Google. And I know the conversation I had with him, Google's philosophy is, please let us get these vehicles on the street. I'm not sure he would say this in a public forum, but he said, if we can reduce the number of fatalities by 40%, by step one, and yet because the technology is not perfect, we still cause some fatalities. Isn't it still better if the net result is less fatality? That's a tough discussion to have if you're the one who has to, now regulate it. Will you allow that to happen and so on? So there's lots of discussion about what happens during this transition.
Yeah, what's the minimum quality of road that the autonomous vehicles need to travel on? I was just driving in northern Arizona through some podunk towns that don't have very good roads. Is there going to be pressure put on them to increase the quality of their infrastructure to accommodate the two autonomous vehicles that come through the town?
It's what's going on is it's a challenge of those who want to have, therefore, put in some kind of infrastructure systems in place so that the vehicle can always tell where it is, or do you have this perfect GPS satellite kind of system?
Of course, I mentioned the parking demo over here in Moorwood parking lot. I have a class that's looking for pavement distress, and that's one of the places we send them to look at. Pavement over there is not great.
Theoretically, if you had the perfect GPS system, and it was really finely tuned, it's okay if you're on a dirt road in northern Arizona. But we're not there yet.
I think this will be the last question.
Okay. Go ahead.
Yeah, we'll cut it off there.
Okay.
Okay, thanks to everybody.
Thank you guys.